Hi everyone, in this video we are going to talk about common collections in Rust. So we are going to talk about three common collections. First, we will talk about vectors, and then we are going to talk about strings, and finally we will be talking about hash maps. In general, common collections provide an efficient way to manage and manipulate groups of related data while taking advantage of Rust memory safety and performance features. That's specifically important and relevant for us because we learned how to manage the memory, and it's a little bit struggling process, but we are going to get there after we got used to the Rust. But during this process, the collections is going to take care of the efficiency and memory part for us, so it's gonna be a lot smoother than we think. So let's move on with the first common collections that we are going to talk about, which is vectors. Let's talk about vectors. Vectors are like dynamic arrays. With arrays, what we had is we had a fixed size of list that we can put our similar types together. With vectors, we can have a dynamic array, meaning that our array can grow and shrink depending on our need. For that, it's going to be stored on the heap, because you may realize that I speak very likely to this statement when we were talking about strings. We said that string literals were the strings that were static and they were stored not on the heap but on the stack, because they were fixed size and we could put them on the stack. But with the strings, since they were growing and shrinking depending on our need, we were storing them on the heap and we were getting the reference and putting it on the stack. So it's like a similar idea with the arrays and vectors. With vectors, but we are having a dynamic allocation for us that is on the heap, and we are going to use this similar to the arrays. So don't worry, it's going to be really similar, and I think it's going to be a painless process. So let's start with creating a vector. There are two ways that we can create a vector depending on our need again. First, I can say let mute numbers equals vec and exclamation mark here, and with this macro we are creating vectors. With the following brackets here, we are going to define our initial state of our vector, and it's going to be 1, 2, 3, and 4, so we will have something in our vector. This is one way of creating a vector, but we can also say let's mute names, let's say, and it's going to be a vector of strings, and then we are going to say vec new here, and it's going to create a new vector for us. If you remember, we were creating strings like this, saying string from. So this annotation is really similar to this one, and we are using the new function here. This is an empty vector we created here called names, and we have another vector which includes 4 numbers and it's called numbers. So let's put underscore here so that our compiler would be happy, and we are going to manipulate this in a second. So let's see how we can add items to our vector. For that, I'm going to say names.push, and this is going to add an item at the end of the vector. And we are going to push and string here. We need to say from, and here we will say Alice. With this, we are going to have Alice here in our vector. With this one, I'm going to say names.push, and our second string here, I will say from, and also Bob. So after this point, we are expecting our vector to be Alice and Bob. So how we can retrieve elements from our vector? So with this way, we edit our strings to our vector, but we also want to retrieve them, obviously. And for that, we can say let first, let's say name equals, I'm going to say names 0. So it's just like the arrays, but I'm adding this reference here so that I can use my element from my vector. And for the second name, I'm going to say second name here, and we will say, you knew it, names 1. Alright, now let's print out the names that we have. For that, we will say println first name is, second name is, and let's do it like this. Here we will have the first name and second name. So let's try this out. I'm going to create a new terminal here, and then we will say cargo build, so that we can build our project and see if everything's okay or not. And then we will say cargo run. As we can see, it says first name is Alice, second name is Bob. So it's very similar to the arrays till this point. What we have is just a little bit different syntax, but the same ideology. Also, we can pop from our array, so meaning if I say names.pop, then what we have left here is Alice. So with push, we are pushing at the end of the vector, and with pop, we are popping from at the end of the vector. So that way we are adding and popping from the end of the vector. Alright. Now let's see how we can iterate through vectors. Here I'm going to say for number in numbers, and inside this I'm going to say println the number is, and then the number we have, and we are going to say number here, and we are expecting it to write 1, 2, 3, and 4. Let's see if it works. As we can see, we got numbers 1, 2, 3, and 4. Now let's see how we can slice a vector. So slicing means what it exactly means, what it exactly sounds actually. Slice is a part of the vector we are getting. So we knew string slices, which is a part of a string. So we are going to create a slice of a vector. For that, I'm going to say let's slice here, and then I will say numbers, and I will say 1, 2, 3, and with this we are expecting to have 2 and 3, because once I set 1 through 3 with 2 dots here, I'm saying start from the first index, not the 0 index, which is the first item in our English language. We say first. In English we start from the 1. In many languages too we use in our daily lives, but in Rust, in many programming languages, we start from the 0 index. So again, here we are saying through 1 to 3, excluding the 3. So what we have is not this, because this is 0 index. The first one, which is 2, and the second one, which is 3. For the third one, we excluded it. So what we have is 2 and 3 here. So that's how we can slice the vectors. To sum up, vectors are a very convenient way to store similar types. We are going to use this a lot, much more than arrays, because in most cases we don't know how many space we want. So dynamic allocation is a very good choice in most cases. But if we knew in advance that how many items that we are going to store, then we can use arrays, which is faster and more memory efficient. But for many tasks that we are going to have, vector is going to be okay to use. And it's not very complicated. We can have vectors initialized with numbers or any type in it. We can have empty vectors. We can push to the vector using the push method here. And we can pop the last element from the vector using the pop function. And also we can retrieve the elements from a vector with this annotation. It's just like the arrays, but we are adding the reference here. And then we can use it the same way that we are using arrays. Now, after the vector, let's once again see how strings work. I know we talked a lot about the strings, but we are going to just talk one more time because it's a very, very important topic, very crucial topic for the Rust. So let's remember how we were creating strings. There were two ways to create strings. First, we can say my string, and then we can say string from, and then I will say my. Alright, this is the first way. Let's create the second way. I'm going to say let's mute second string, and I will say second string dot toString, and this method converts our string slice here to an actual string. And then we can add to the string by saying my string dot push str, and then I will say string. Let's see if this worked. I'm going to say println. We will just print this. Let's say my string here and try this out. As you can see, we got our my string here, and that's how we can add to our strings, since strings are basically collections of characters. So they work like vectors, and with vectors we were pushing at the end of the vector with the push method. With the push str, we are actually pushing at the end of the string with the same ideology with the vectors. but vector we were pushing one item. Here we are pushing couple of items, and our items are the characters here. So this S is a character, T is a character, and then we are pushing this many characters at the end of this many characters. So it's the basic ideology of the workings of the vectors that we are using with strings. So let's see how we can iterate in a string. For that, we already have my string. We are going to iterate through my string. Here I will say for C for character, and I will say in my string dot chars. So this function here gives us the characters. So after this function, what we have is an iterable string, and every item of that string is a character in the string. And here we are going to do the same thing we did before. We are going to say println, and then we will print the character here. Let's see if this works again. Never trust me. And as you can see, we have our my string with the space here. So this is the first way to iterate through strings using the chars here, characters here. But we can also iterate through bytes, not the characters, because not every character is equal bytes. Some characters are more bytes, some characters are less bytes, depending on the language that we are using, and we are encoding this characters with different amounts of bytes. And let's use bytes this time, and for that I'm going to say let's be in my string dot bytes, and here we will say println, and the same thing with b, and let's see what's the difference. And as you can see here, instead of the characters we have the bytes. So there are two ways to do this depending on your need, but in 90% of the cases I believe that what we are going to need is characters instead of the bytes. But especially when we are working in some specific technologies, and one of them is actual blockchain, we will make use of these bytes. Now that we also looked into strings, we already knew the strings, but now we remembered them once again after seeing the vectors. I think it's useful because the vectors are strings working in a very similar way. Just reviving strings after the vector is a good practice, and also we saw how to iterate through the strings. Now let's look at the hash maps and how we can work with them. So what is the hash map? Hash maps are basically dictionaries if you have used Python. So the difference between hash map and a vector is that vector has just one item, and then it has another item, and it goes like this. With hash maps, what we have is actually a key value pair. So we were saying the 0 index is this in the vector, and the first index is this, second index is this, and it was going like this. So we were saying 0 index as the key, and as the value we were pointing to the item that is in the index 0. But with hash maps, what we have is a key that we can actually define, and then we have a value that this key corresponds to. So let's create the hash map. How it actually works is going to be much simpler than my talk, I promise you. First, to use the hash maps, we need to say use std collections, and under the collections hash map. So with this line we are saying we want to use the standard library, and from this library we want to use collections, and the collections that we want to use hash maps. So that's basically importing hash maps to our project. If you have used JavaScript or any other language, then I guess you are familiar with importing, and we have a separate section just to talk about this, so don't worry, we will talk about this in much more depth. But for the purpose of this example, just know that this is how we can include hash map in our project. After including the hash map, I'm going to create my first hash map here. I will say let's mute scores, and I will say hash map and new. It's just like the vectors. And then I'm going to add to my hash map. If you remember, with the vectors we were saying push, with the string we were saying push str, and with hash maps we are going to say insert. With the insert we are actually inserting key value pair instead of one item. So let's see how it works. I'm going to say scores.insert here, and inside this we will have a string as the key. You can choose any type for your key. We are choosing string here, and then we will say Alice because we got used to the Alice, and we will say 10. So we can think this as this is Alice and this is the number of tokens Alice store if we are working on blockchain, or it's applicable scenario for many different places. And that's the way to insert items to our hash map. And at this point we are expecting it to be something like this. It will be Alice, and as the value we will have 10. So this will be one insertion. And if we have another insertion, if we say scores.insert, and here we will have our key, we will say string from, and then we will say Bob, because we already knew Alice, so we just use Bob. And then we will say 20 here, and at this point we are expecting to have Alice 10 and Bob 20. So that's the way how we can insert new stuff to our hash map. And now let's see how we can retrieve from our hash map. To retrieve item, we are going to say let's say Alice score here, and then we are going to say scores.get. So the method that we are using is get, and then we will say we set reference here as we said in the vector, and then we are going to say string from Alice. Here we are basically saying get me the value of the key Alice. Since it's very long to write Alice as a string, that's why we have this big line here and we are using the reference. But what we are basically saying is that just retrieve me the value corresponding to this key Alice string here. Let's see if this works. We are going to say just the brackets here, then Alice score, and we are going to check if it works. Alright, and this also should be a hash map. So as you can see, we are having an error here, and in this error we are having this because actually Alice doesn't return the value that we put in there. It returns an option that holds our value, because if we give a wrong key, then the result will be none from the option. And using this, we are actually checking for the errors, so we are making sure that our code is going to work fine. So to print out a value, which is an option, we should add here the semicolon and the question mark, which should solve the problem. And here we are going to say cargo run. As you can see, we have sum 10 here as the value, because as we talked, what we have here is option, not the value itself, and that's a mechanism to check for the errors, since we may try to retrieve a value that doesn't have that corresponding key, or we are just putting the wrong key. For these situations, we have the option type to cover these situations, and just keep in mind that we are working with option values here. And if you want to print out the hash map, we can do it like saying println, again, same thing here as our debugger, and then we are going to say scores here. And if we run this, as you can see, we got the whole hash map here, and as the key we got Alice, and as the value we got 10, as the key we got Bob, as the value we got 20, and as you can see, it's really similar to the dictionaries in Python, and it's also very common structure, data structure in many popular programming languages. So there's nothing special here on the Rust side, but what's special is that we are actually getting the values as option. That's unique to Rust, because the option is unique to Rust, and with the system we are not getting a null value, because in many other programming languages, if you are trying to get a value with a key that doesn't exist, what you are going to end up is an error. But here what we are going to end up is actually none, which is an option type, so our code will still be working and it won't crash, and that's where Rust shines. So Rust, as you can see, does the same thing with the other programming languages, but we are including more safety and control for the developer and smoother experience for the user. And now let's see how we can remove an element from the hash map. To remove an element, we have a really easy method. Let's say we are going to say remove here, and then we are going to provide the key that we want to remove. We are going to say string from, and I want to remove Bob, let's say. And after that, we are going to print this again. Now the only pair we have is Alice and 10. And now let's look how we can iterate through the hash map. So iterating through the hash map is very similar to other iterations that we did here, like the vector and the string. But the only difference is we have two items instead of one, since we have not only the value, but we also have the key. For that, I'm going to say for, and I will say key value in scores. I'm putting this reference here so that I can use the scores later. And then I will say println, and I will just print the value here. Let's also print the key. So here I will say key, not lee, but key, and then the value. Let's run this, and as we can see, we have Alice and 10. This is the key and this is the value. So difference is that we have a tuple here which holds the key and the value. Inside this loop, we can use this key and value separately if we need it. So that's it for the hash maps, and let's review what we did with the collections. In this lesson, we learned about the common collections, and we learned about the most used three collections, which are hash maps, strings, and vectors. Vectors are really common in Rust because in many situations, as we talk, we need a dynamic array which corresponds to a vector in Rust. And strings are everywhere, as you can see, and we can use strings after we know how the strings are constructed. Finally, we learned about the hash maps. And hashmaps was new to us, but we just solved that. It's even new to our lesson here. It's not new to Rust. It's very common with other programming languages too. And we saw how Rust handles hashmap in terms of error handling. So thank you very much. I'm going to see you on the next lesson.